In this tech tip video, we will show and explain how to create a Y-axis or free turn tool with NX2312. When the tool is open or converted in NX modeling, we start by rotating the tool in absolute coordinate system by using either the move component or move object command. This depends on the structure. If the tool consists of an assembly structure with part components, we use the move component command. If the tool consists of bodies, we use the move object command. In this example, I have bodies and will therefore use the move object command. We start by selecting tools in the top ribbon bar, then we select move object. When dialog shows up, we select the tool bodies. Select the specify orientation and using the spheres between the axis vectors to rotate the tool. Move the length of the tool into positive X direction in the ACS. Orient the rotation of the tool by using the modeled index notch as reference. This represents the initial tool position, and this should be oriented as seen in current picture, related to the ACS. Now we will move the tool mount junction into ACS 0. Make sure the tool components are selected. Toggle on move handles only. Specify the coordinate position in the tool mount junction. Toggle off, move handle only, and adjust the axis value to 0. This is how the tool should look like if all steps were implemented correctly. Now let's watch a recording of the workflow. First I go to top ribbon bar, Tools, then selecting Move Object. When the dialog shows up, I select the tool bodies. Then selecting Specify Orientation, I start with inspecting the tool to see around which axis the tool needs to be moved to end up in correct position in the absolute coordinate system. By looking at the current position of the tool and where it needs to end up to have the tool length pointing in X plus direction, the tool needs to rotate 90 degrees around the Y-axis. The second rotation in this case to take care of is the position of the index notch. The index notch is important for reference when it comes to the initial tool position. Let's start by rotating the tool 90 degrees around the Z-axis to see where it ends up. We can now see that an additional rotation of 90 degrees is necessary to correctly position the tool, with the index notch pointing down and in plus Z-axis direction in ACS. We press Apply to confirm our changes, and continue by moving the tool mount junction into ACS 0 position for all axes. In the Move Object dialog, I need to reselect the tool components again, and then we toggle on Move Handles Only. Select Specify Orientation. Set a point in center of tool mount position. Press OK. Now deselect the Move Handles Only, Edit Point dialog, and set all axis values to 0. Press OK. Now let's shift to manufacturing mode. We switch mode by in the top ribbon bar, selecting Application, then Manufacturing. When the dialog about the templates shows up, we select Cam_General and the Mill_Planner Cam setup. One of the first things we can start to do is to delete the existing MCSS. Now we need to orient the WCS. This is important for the display of the inserts and to get them in the correct position and plane. Since the parametric tool is displayed in the WCS, it will help you a lot when setting up the tool if this is correctly set. When it comes to Y-axis turning tool, it's easy to get confused in the thinking because of the different orientation. But it doesn't have to be that complicated. How to set up the WCS for this free turn tool? Use the WCS Dynamics option. You find it either by searching or you go to Menu, Format, WCS Dynamics. The position of the WCS is not as important as to have it correctly oriented. This because the parametric insert is displayed in the 2D plane of X and Y axis, and therefore for this tool, the WCS orientation should be so that Z-axis plus direction point away from the insert. Y-axis points towards the center, and X plus direction point to the right. When specifying one or multiple inserts, you can reorient the WCS for each new insert position. Then the new tool will use the current position of the WCS. Or you can use the Specify Tool Tip junction inside the tool dialog to orient insert coordinate system. In this video, we will use the second option by specify and orientate the inserts with the Specify Tool Tip junction. We start by creating a new multi-tool from the turning template. When the multi-tool dialog shows up, insert a description of the tool. Insert a library reference. Toggle on Export Tool Part File. Select Specify Mounting. If the tool was correctly set and aligned, we shall have the correct position. Select the non-cutting portion of multi-tool, and then press OK to confirm the settings and close the tool dialog. We delete the sub-tools inside of the multi-tool that we do not have any use of. If we need, like in this case, to create a third tool, then create a new insert, toggle off the adapter, and toggle off the holder. Make sure the holder angle is set to 0, then press OK to close the tool dialog. We move the tool so that it becomes a child to the multi-tool. When we create a new tool that shall be used inside of a multi-tool, we need to customize the dialog and add the index notch and incremental turret rotation manually. Click right mouse button on the new created insert. Select Object Customize. Select the tab page, More. Set the dialog item type to customizable. Select the index notch and incremental turret rotation and press Add to Dialog, then OK. When edit the tool dialog, inside More tab, we should now see both index notch and incremental turret rotation. This step is not necessary to do for the inserts that followed during the multi-tool creation. Important: do not copy and paste an existing subtool for reuse. This can lead to problems when later using the multi-tool in programming. Now let's define and set up the first insert. First, make sure Export Tool Part File is toggled on. Define ISO insert shape. Specified correct values for nose angle and radius. Specify orient angle. This I will show how to measure later. Optionally is to set a library reference. We can now also specify the cutting portion of tool and the tool holder. Sometimes it can help to switch to tracking point view and define the current tracking point as a P9 when setting up the insert. By doing that, we have the insert radius in the center. Give the tracking point a meaningful name. This will be useful later on in CAM programming if the insert is defined with multiple tracking points. Also, make sure to specify a unique number for adjust and cut COM registers. Now, we can switch back to the tool view and specify the tool tip junction. When doing that, we have some geometries on the tool that we can use as support reference. We start by setting the tool tip junction in center of radius of the insert. Then we start to correctly align the axis. Here are some examples of how to align the axis for the tool tip junction for this tool and insert. For the x-axis, we can use the vector from the edge, as is shown in the picture. For the z-axis, we can use the face on the bottom of the insert. And for the y-axis, we use the face on the holder, as is shown in picture. When the tool tip junction is aligned, we can measure and define the orient angle of the insert. To measure the orient angle correctly, open the Measure tool. Set the first vector in the positive direction of the x-axis orientation of the tool tip junction. Specify the second vector we set on the cut edge pointing towards center. That gives us the measured angle result 72.5 degrees, which we now can insert into the orient angle inside of the tool dialog. The last values we need to define for the insert is the index notch and the incremental turret rotation. Let's start to have a look at how to measure the angle for the index notch. Orient the tool into the initial tool orientation. This is how the tool most likely will be mounted in the tool spindle of the machine. If we rotate the tool 90 degrees and look at the tool from the bottom as shown in picture, with cutting edge 2 pointing down. This is how the tool should be measured and the values for index notch to be inserted. Open the Measure tool. Use the face geometry for the index notch to specify the first vector. In this case, the vector should point in negative direction of y-axis in absolute coordinate system. Specify the second vector. We can use the face on the holder as reference, this vector pointing in same direction as the insert we setting up does. If we are not sure that we can use face on the holder as reference, we can also set 2 point to get the vector. One in the center of the tool and one in the center of insert radius. When the second vector is specified, we will get our measured result. The angle option should be set to outer angle. We can see that our measured value is 240.0 degrees. This is what we will insert into the index notch value inside of Tool Dialog for Insert 1. For the incremental turret rotation value, we can directly insert value 90. This value is set to 90.0 for all inserts that's used as free turn/y-axis turning tool. When all the data is specified for the inserts, we can export the multi-tool to library. Now we will show a recording of the workflow for setting up the tool and all related inserts. We start by switching application to manufacturing. We select cam_general and the mill planner template. First thing we can start to do is to delete the MCS. Next thing is to specify and reorient the WCS. I prefer to place it in center of one cut edge, but that's not so important. The important thing is to correctly align the axis. The turning insert are displayed in XY plane. Align the axis so that Z points away from the bottom of the tool, Y points towards center, and X point to the right. We create new multi-tool located inside of the turning type. Give the tool a description and library reference. Toggle on Export Tool Part File. Specify the tool mount junction. Select the non-cutting portions of multi-tool. Press OK to confirm and close Tool Dialog. We can delete the sub-tool types that we will not use for our tool. This tool needs 3 inserts, so we create a new tool for the last insert. Important: do not copy-paste the existing subtools. This can lead to problems later on when using the tool in programming. We toggle off the adapter and the turn holder. Also make sure the holder angle is set to 0. When we go to the More tab inside Tool Dialog, we are missing 2 important tool parameter settings: the index notch and the incremental turret rotation. This parameters can be manually customized into the tool. Select the tool and click right mouse button. Select Object, then Customize. In the Customize dialog, select Tab Page More. Change dialog item type to customizable items. Multi-select index notch and incremental turret rotation. Press button. Add to dialog. If we select Display Dialog, we can now see that both values appear in the tool. Now close Preview window and then press OK to close the Customize dialog. Let's change the names for the inserts to make it easier to identify them. Let's start by giving the insert a library reference. This I plan to copy to the other inserts and just changing the last number. I then change the insert shape to user-defined. Specify the nose angle and nose radius. Let's jump over the orient angle for now. We come to that later. We can specify the cutting portion of the tool and the tool holder. To make it easier, I prefer to change the P number to a P9. By doing so, I have the tool reference in center of radius. so that when we specify the tooltip junction, it's easier to see that the insert is correctly positioned. If I don't want to use the P9 for my tool, I change it at the end when I have specified my tool parameters. Now we can specify the tooltip junction. The origin of the coordinate system should be placed in center of tool radius, and the axis orientation should be so that Z point away from the insert, Y points towards center, and X-axis points to the right. The X-axis is used as angle 0 reference when we specify the orient angle for the insert. Now let's measure the orient angle for the insert. Use the Measure tool located inside of Analysis in top ribbon bar. Inside of Group Object to Measure, make sure Vector is selected. Specify the first vector in same direction as the X-axis is set for the tool tip junction. Either use the tool model as reference for finding the correct vector or the vector coordinate system. For the second vector, select the cut edge of the insert with vector direction point towards center. Now insert the measured value into the insert orient angle. Last things to specify for the insert is the index notch and incremental turret rotation. Use the Measure tool with vectors selected. To measure the angle for the index notch, we use the modeled index notch on the tool as reference. Select the bottom face of the notch so that the vector points down in same direction as insert 2, or in absolute coordinate system, minus y-axis direction. For the second vector, use the tool model as reference or the point-to-point option. With this option, we set the first point in center of the tool and the second at the center of tool radius. Now we need to change the angle option for this cut edge. To measure the index notch angle for this tool, all the angles should be measured counterclockwise if we look at the tool from this direction. For the second insert, the index notch value will be 0 due to the direction, and the third will get value of 120. We insert the measured value into index notch parameter. When it comes to the incremental turret rotation, when we have a free turn or y-axis turning tool, we can always set this to 90.0 for all inserts. Now when the first insert is finished, let's copy the library reference and continue with the second insert. For the remaining inserts, there will not be any voice support. This because we are using the same workflow as for the first insert. Now, when all the parameters for the inserts are defined, we can export the multi-tool to library.